Hello everyone, welcome to this session on the number system presented by Savi Murali Knowledge Hub. I'm sure that you know how important this chapter is as many questions come from the number system in various competitive exams. I encourage all of you to take this as a challenge. After reading the question, you can pause the video for a while and try to solve the question by yourself. Later, you can verify your answer or get to know the solution by watching the remaining video. Without further ado, let us begin the CSAT Challenge series. Let us solve the first question. On dividing 3,97,246 by some number, quotient is 865. The remainder is 211. Find the divisor. Since school days, we have learned that the number which is getting divided is referred to as dividend, and the number which is dividing is referred to as the divisor. When dividend is divided by the divisor, number obtained is called as quotient, and the remaining number, or even if it is 0, this is referred to as the remainder. We have also learnt a particular formula in school, if you can recollect it. Dividend is equal to divisor into quotient plus the remainder. So to avoid confusion, we have named dividend as capital D, divisor as small letter d. We just have to use this formula in order to arrive at the answer. Dividend is given to be 3,97,246. Divisor is unknown, so let us keep it as it is. Quotient is given to be 865. And the remainder is 211. We just have to simplify this particular equation to arrive at the answer. 3,97,246 minus 211, so this is coming to the left hand side, is equal to 865 into divisor. So when we simplify this particular equation, the value of divisor obtained is 459. So this is the final answer. Let us now solve the second question. In a two-digit prime number, if 18 is added, we get another prime number with reversed digits. How many such numbers are possible? You should carefully understand the question. Now we have a prime number, let us call it PQ. P and Q are those two digits. If 18 is added to it, we get another prime number in which the digits are reversed compared to the original number PQ, which means what? The answer obtained is QP. So this is the basic equation. We should also know its value because Q is the units place and P is the tens place. Similarly here P is the units place and Q is the tens place because the digits are reversed when 18 is added to PQ. Now with respect to value, if we write, this becomes 10P plus Q plus 18 is equal to 10Q plus P. So let us further solve this equation. 10P minus P plus 18 is equal to 10Q minus Q. That is 9P plus 18 is equal to 9Q. I can also bring it to one side. So what we can do is 9Q minus 9P is equal to 18. 9 is common here. So 9 into Q minus P is equal to 18. 9 ones are and 9 twos are. Therefore, the difference between the two numbers, which is Q and P, is equal to 2. So this is something to keep in mind before we go to the next step. So now we want two-digit numbers, right? So I'll just write the first digit of the number 1, 2, 3, 4, 5, 6, 7, 8 and 9. So now we should write the number such that the difference between the first digit and the second digit is supposed to be 2. So I can write here 13, here 2 plus 2 is 4, here 3 plus 2 is 5. So likewise I can write 46, 57, 68, 79. Here there is no need to add because when we add 18 to it, what happens is we get a 3-digit number. So we don't even have to consider 8 and 9. Now when 18 is added to each one of this, let us see what is the resultant because that is most important. So here we get 31. In this case we get 42. Here we get 53. You can solve it by yourself. And similarly, we start getting the numbers. And with respect to 57, it is 75, 86, and here it is 97. So we can clearly see that some of the numbers are not even prime. So the reason why I did not solve this is I can clearly see that this is not a prime number at all. PQ is supposed to be a prime number because it is clearly saying in a 2-digit prime number. It is not even a prime number. Similarly, this is not even prime. What is prime? It should be divided by the number itself and 1. Right? So we don't even have to consider all of this. So very clearly, the first one is a possibility. Because 13 is a prime number, 31 is also a prime number. So this one possibility is there. So when we consider this case, 57 and 75, 75 is not prime. According to the question, we get another prime number when 18 is added. So even this is cancelled out. Of course, this is also cancelled because both of them are not prime. When it comes to 79 and 97, yes, that is considerable because both of them are prime and very clearly the numbers are reversed. The digits are reversed when 18 is added. Therefore, how many such numbers are possible? 2 such numbers are possible. Which are those two numbers? 13 and 79 becoming 31 and 97 respectively upon adding 18. I hope this is clear to all of you. Let us now go to the third question. Let x, y, z be the 3-digit number. X plus y plus z is not a multiple of 3. xyz plus yzx plus zyx is not divisible by. Okay, so let us solve as per the given data. So now xyz plus yzx plus zxy. We can write this with respect to value as we just did in the previous question. So this is going to be 100x plus 10y plus z. So when it comes to yzx, so what is it? It is 100y plus 10z plus x. Similarly, this is 100z plus 10x plus y. I hope you know why I am writing like this. It is with respect to the value. Units place, tens place and 100 place. Same thing is applicable to the remaining two numbers as well. So we can simplify this further because there is 100 common, right? So what I can do is 100 into x plus y plus z. Similarly, there is 10y, 10z and 10x. So plus 10 into x plus y plus z plus what is remaining? So another remaining term is z, x and y plus x plus y plus z. This is another set. So as you can clearly see, x plus y plus z is common. So what I can do here, so remaining things can be added. That is 111 into x plus y plus z. So as we can see the options, here this number is certainly divisible by x plus y plus z. So this option is ruled out. Option D is ruled out. So now we should factorize 111. This can also be written as 3 into 37 into x plus y plus z. So therefore we are ruling out two more options, which is 3 as well as 37, because this particular expression is obviously divisible by 3 and 37. We have already ruled out x plus y plus z. Therefore 9 is the number by which this expression cannot be divided. 9 is the answer. So all we have to do is factorize it properly, and we should clearly know one thing. Any number which is divisible by 3 need not be divisible by 9. But the numbers which are divisible by 9 are certainly divisible by 3. So we should keep this in mind and we should not get confused. Now the next question, question number 4. Let A3BC and DE2F be the numbers in which letter represents a different digit greater than 3. So let us write it as we study each of the data. So there is a number called A3BC. There is another number called DE2F. In that the letters ABC, also D, E and F are different digits, but all of them are greater than 3, which means what? The numbers can start itself by 4. So it can be 4, 5, 6, 7, 8 or 9. So it can be any of these. Because it is greater than 3, we should not even include 3 unless they give greater than or equal to. Some of these numbers, so kindly correct this. So it is not SOME, it is SUM. Sum of these numbers is 15902. What is the difference between A and D? So let us try to solve this. So we know C plus F here, so must be equal to 12. Why not 2 as seen? So that is because here B plus 2 is coming to be 0. All of these are supposed to be positive numbers since it is greater than 3. So what we can know here is C plus 5 is equal to C plus F is equal to 12. This is the first interface. As we see immediately, what we can write is C plus F is equal to 12. Now B plus 2 is equal to must be 10, right? So that is why the 0 digit has come over there. Therefore, the value of B is equal to 8. So one value we have got. So one of the values is already there. So now coming to this one, 4 plus E. I am writing 4 plus E because one carrying would be there. So 3 plus 1 would be 4. 4 plus E is equal to 5. I'm sorry, it is 9. 4 plus E is equal to 9, this digit. So when we further simplify this, the value of E is equal to 5. So now what are we supposed to find out? The difference between A and D. So now the sum of A and D, as we can clearly see here, sum of A and D is 15, right? A plus D is equal to 15. Then what is A minus D is the question. A minus D is equal to question mark. So we need to find out with the help of possibilities. If the value that we know with respect to E is 5, A plus D is 15, the possibilities are, see, we have to rule out in this particular number. But the reason why I have written this prior is we have to now start cancelling out. E is 5, cancelled out. B is 8, cancelled out. Now what we want is A plus D being 15. So what are the possibilities? So if we take 9 and 6, it is possible. But if we take 7 and 4, we will get just 11. It won't be equal to 15. So the possible numbers are A and D could be 6 and 9. It can be reversed also 9 and 6, but ultimately we want summation of these two numbers and difference between the two numbers. If the summation of these two is 15, so as per the demand of the question, what is the difference between A and D? It is 9 minus 6, which is equal to 3. Therefore, the correct answer for this question is option 3. Option C, which is 3. Now question number 5. A number has 3 digits. So let us consider the number to be X, Y and Z again, just for the convenience. Middle digit is 0. That is Y is equal to 0. The sum of 3 digits is 4. That means X plus 0 plus Z is equal to 4. I can as well write X plus Z is equal to 4. When the first and last digits are interchanged, it gives a number which is greater than the number itself by 198. What is the difference between first and the last digit? So if XYZ is considered, this is the possibility. Suppose we reverse it, meaning I take ZYX. You can clearly see the place of Y is not getting changed. We are only interchanging the first and the last digit. So if we do this, then what happens? It gives the number which is exceeding XYZ by 198. All we have to do is the same formula again. Consider the units, tens and hundreds place. Write the value of each one of this. This is going to be 100Z plus 10Y plus X. That is the value of ZYX. Here it is 100X plus Y plus 10Y is what I meant to say, plus Z. And here this is retained plus 198. Further, when we simplify, it's going to be 100Z minus Z. taking this from RHS towards LHS. So it becomes minus Z plus 10y here on the opposite sides gets cancelled, plus x minus 100x going to the LHS. Therefore, it becomes minus 100x, and what's remaining on the RHS? It is 198. So when we simplify this further, 100z minus z is 99z. 100x minus 100x plus x is minus 99x, gives 198. So here common number is 99, right? So therefore I take 99 outside, into z minus x is equal to 198. So clearly it is 99 2 times is 198. Therefore the difference between the two digits x and z, or I can even call it z and x, because ultimately we don't need the order. We just need what is the difference between the two digits. Therefore the difference between z and x, we can also call it difference between x and z, is equal to 2. Right? So the final answer is equal to 2. Let's now go to the next question. How many numbers between 99 and 1000 have digit 8 occupying the unit's place? This is Civil Service Examination UPSC 2017 question from the paper 2. So now since we are supposed to start it from the 3 digits, because 99 is a 2 digit and of course there is no 8, immediately we have the 3 digit number which is 100. So we'll start with 108, 118, 128, so on. It goes all the way up to 198. Similarly, we have another row that can be created, 208, 218, 228, all the way up to 298. Similarly, 308 and its series. Likewise, we can go up to 908, 918. So 928 all the way up to 998. So we cannot go further because the upper limit is 1000. The lower limit is 99. So we have planned it in a well defined boundary. It is between 99 and 1000 as per the demand of the question. Now this particular horizontal row has 10 numbers, 108 up to 198. If we count, there are 10 such numbers. And here if we count the vertical column, so in this vertical column there are 9 such numbers. So the final answer is 10 into 9, which is equal to 90. Therefore 90 such numbers are there between 99 and 1000 that has digit 8 occupying the unit place. I hope you understood this. Now the 7th question, what is the total number of digits printed if a book containing 150 pages is numbered from 1 to 150? So this is one of the beautiful questions from the PYQs, and recently in many examinations similar questions have been asked. So let us try to solve this. There are totally 150 pages in a book. The number starts with 1 and ends at 150. How many digits are printed? We know the final number is 150. We don't need the final number or beginning number. We need how many digits are printed. So between page number 1 to page number 9, all the way up to this, there is only one single digit printed. How many numbers are there? 9 such numbers are there. Therefore, 9 digits are printed up to page number 9. So let us write how many digits are there here and how many such numbers are there over here to avoid the confusion. Now, from page number 10 all the way up to page number 99, how many digits are there? It's a 2-digit number all the way from 10 to 99. How many such numbers are there? Here we should not make mistake. Many students tend to make mistake over here. All we have to do is 99 minus 10 plus 1. This one, right? So 99 minus 10 plus 1. We are supposed to count it. So therefore this becomes 2 into, here it's 90. Because 99 minus 10 is 89. 89 plus 1 is 90. How many digits are printed? 180 digits are printed. So total number of pages is 150, right? So we should go further. Page number 100 all the way up to page number 150. 3 digits are printed. And how many such numbers are there? Number of pages. So it is 150 minus 100 plus 1. Right? So which is equal to 51. And here the number is going to be 153. So when we take the summation of all of these, the total number of digits that are printed, 180 plus 153 plus 9, which is equal to 342 digits. So therefore, what is the total number of digits printed? 342 digits are printed in a book containing 150 pages numbered from 1 to 150. Now the next question. A printer numbers the pages of book starting from 1 and uses 3089 digits in total. How many pages does the book have? This is a question similar to the previous one, but with a small twist. Instead of giving how many pages are there, now they have asked how many digits, they have given how many digits are printed, and we are supposed to find how many pages are printed, or total number of pages. Right, so we'll start this. So same way, page number 1 to 9, just now as we have solved here. So here we'll take the number, here we'll take the digits. So number is 9, digit is just 1. Page number 10 all the way up to page number 99. So totally 90 numbers are there with digit 2. Therefore 180 digits are printed. Page number 100 to page number 999, because when we go to 1000, that's going to be 4 digit, right? So we'll restrict till here. So numbers, how many numbers are there? 999 minus 100 plus 1, which is 899 plus 1, 900 such numbers, 3 digits in each. So when we multiply the two, we get 2700. Let us see what is the total as of now. So when we do the summation of 2700 and 189, we have 2889. But how many have they given? 3089, which means this particular book has more than 1000 pages. This one thing should be clear to all of us. By looking at the option, in case they have given any 3-digit number, we can eliminate it. So let us go further here. They have given what number? 3089. Up to 999, how many digits are printed? 2889. We just take the difference between the two. The difference between the two is 200. So in order to have 200 more digits, how many pages should be printed? So now we should not consider 3, because the immediate next number is a 4-digit number. Page number 1000 has 4 digits and we want 200 more digits. So 200 divided by 4. Therefore 50 more pages, right? 50 more pages have to be added. So 999 plus 50. So this is going to be our final answer, which is 1049. Right? So we should be very careful in the last step. We need 200 more digits so that the total is going to be 3089. If we have to get 200 digits, how many pages should be there? We know up to 999. The very next number is 1000, that has 4 digits. So 4 digits, one number, 200 such digits should be there. So 200 divided by 4 gives 50. Therefore 999 plus 50, that gives 1049 pages. So the final answer is, in this particular case, the book starting from page number 1, it is supposed to have total page numbers up to 1049 in order to have 3089 digits in total. I hope this is clear to all of you. Question number 9. In an objective test of 90 questions, 5 marks are allotted for every right answer and 2 marks are deducted for every wrong answer. After attempting all 90 questions, a student got 387 marks, which is quite good. Find the number of incorrect responses. So this is an interesting question and we should carefully look at the given data. So let us consider number of correct answers, number of right answers to be X, and number of wrong answers to be Y. So now what we know, total number of questions is equal to 90, right? Number of right plus number of wrong, this should be equal to 90. Let this be equation 1, like how we used to solve in the college. Of course, we don't get so much time in the exam, but we need to know what is the methodology and go on in the same procedure quickly as possible. So for each right answer, 5 marks is avoided. So 5 into x. What is the total marks secured by getting correct answers? 5 into x. And they are going to reduce the marks for the wrong answers, 2 marks, right? So 5x minus 2y. So by doing so, the student has scored what marks? Student has scored 387 marks. So we have two equations already, right? 5x minus 2y is equal to 387. This is our equation 2. We just have to solve equation 1 and 2 to get this. So it is a simple thing. Multiply equation 1 by 2. So what do we get? So I'm just going to solve this. I hope you're doing it simultaneously. 2x plus 2y is equal to 180. So even RHS we should multiply by the same number. 5x minus 2y is equal to 387. So add both the equations. So plus y minus y gets cancelled when we add both of this. So what do we get? 7x is equal to 567. We should be very careful in simplification, because even if we know the procedure, if we fail at the simplification, our answer will not be correct. So the value of x is equal to 81. So what is x? The number of correct questions, the number of questions that a person has marked it correctly, right? Then what is y? Total number of questions is 90. So if x plus y is equal to 90, 81 plus y is equal to 90, therefore the number of incorrect questions is how much? It is equal to 9. Therefore the number of incorrect question a student has answered is equal to 9. So that is going to be the final answer. So let us recheck the question. Identify the number of incorrect responses. The number of incorrect responses is equal to 9. So it is a simple question. We just have to form the right equations and simplify it properly. So let us now go to the next question. Question number 10. There are certain 2-digit numbers. Difference between the number and the one obtained on reversing it is 27. How many such 2-digit numbers are there? So for our convenience, let us consider the numbers to be x and y. So certain 2-digit numbers. And the difference between the two numbers is equal to and the number obtained by reversing it, that is xy minus yx is equal to 27. This has to be clear, right? There are certain 2-digit numbers. Difference between the number and the one obtained on reversing it, which is yx, right? So difference between the two numbers is equal to 27. How many such digits are there? So now when we simplify this further, as we have done with the help of the value, this is units place, this is tens place. That should be extremely clear. So 10x plus y minus 10y. So this is minus of, that also should be there in our mind, minus of 10y plus x is equal to 27. So let us solve this further. We have 10x minus x minus 10y plus y is equal to 27. So this is 9x minus 9y equals to 27, or x minus y, 9 taking common, 9 3s are 27. Difference between the two numbers has to be 3. Now let us apply this. So we know the relationship between the digits x and y. Difference between them has to be 3. Right? So I'll write x first, x comma y, right? This is the order x comma y. I'm going to write x first. So 1, 2, 3, 4, 5, 6. I can't take 7 because if 7 and 3 are there, it will become a 3-digit numbers, right? So I cannot consider 7. What is y now? So difference has to be 3, which means this can be 4. This is 5, 6, 7, 8 and 9. So what are we supposed to identify? Now the difference between the digits upon reversing must be equal to 27. Since we have already found out the algorithm, all these are going to be the possibilities and the answer would be equal to 6. So the reason why we do this is to actually bring down the large area, right? So we have to actually go to a narrow spectrum in order to identify the answer, because there are so many two-digit numbers. So we need those numbers. When we reverse those digits, right, the difference between the two has to be 27. Let us cross check, right? So 14 and 41, so modulus L, right? Otherwise we get negative number. So when we take the modulus of 14 and 41, the difference is going to be 27. You can check for any of them. 52 minus 25, 63 minus 36, 74 minus 47, 85 minus 58, and 69, which when taken difference with 96, all of them gives the number 27. Okay, you can just cross check it quickly. Therefore, the easy method is just bring down this equation into the value form and then simplify it carefully. We come to know what should be the relationship between digit x and y. Just identify how many such numbers exist, right? Later you can cross check. So I hope this session was useful to all of you. Thank you so much for your time and patience. You can let me know in the comment section if you want me to make any changes. I'm going to bring 15 more number system questions in part 2. Thank you one and all. Happy learning.